Hey, grade sevens. Oh, I just bit my tongue. On to the next section. We're solving one-step equations still. So we're just doing one step. So last time we were solving one-step equations, but just involving addition and subtraction with the variable. Now we're going to be looking at multiplication and division. So some number a being multiplied by x, which is equal to b, and x, our variable, being divided by. So right now I'm using this slash as a division symbol, just because I couldn't actually enter in the fraction symbol on here in any way. But we also write it x divided by a is equal to b. Now I've written our division in different ways. I'll probably keep coming back to this fraction form, because that's mostly what you'll be seeing from now on in math. So our variable x being divided by a number, which is equal to another number. So there's just one step that we need to do to solve these. So let's look at how we do this and just sort of visualize this again. So we have 3x is equal to 12. Okay, we're working on this problem here. Let's envision our teeter-totter seesaw. I have 3x. So I have x, x, and x on the one side. And I have 12 on the other side. Whoops, not supposed to be a line in there, but you get the idea. There we go. I have 12 counters on the other side. So if I want to figure out just what 1x is equal to, so not 3x, 3x is equal to 12, how much is 1x equal to? I could get rid of 2x's, but I don't exactly know how many counters 2x's is. But in another way I could think of it is by dividing by 3. When I divide the 3x's by 3, if I only have 1/3 of these x's, I'm only going to have 1x. If I divide this by 3, if I divide 12 by 3, if I make it into 3 groups, well, now I have 4 in each group. And when I divide it by 3, how much is in just one of those groups? There's 4 counters. Okay, so I'm dividing on each side to keep my equation balanced. I divided by the same thing, so my equation stays balanced and I can solve it. So how we would write that is I'd say, well, and I always look what is being done to my variable. So x is being multiplied by 3, so I'm going to do the opposite and divide by 3. The best way to show that is with this fraction symbol. Okay, and 12 is going to also be divided by 3. So I've divided by 3 on both sides of my equation. So my equation's still balanced. It's still true that this equals that. But these 3's cancel out, because 3 divided by 3 is what? Well, 3 divided by 3 is 1. So 3x over 3 is actually just 1x, which is what we're trying to find. And 12 divided by 3 is 4. So x is equal to 4. Okay? So do the same thing on both sides, the opposite of what is being done to the variable. So let's look at this problem. I have x divided by 5, which is equal to 4. I'm going to rewrite it as x divided by 5, which is equal to 4, because that's how it will actually usually be written. So x is being divided by 5, that's equal to 4. So I want to do the opposite of what's being done to my variable, which is multiplying. Multiplication is the opposite of division. So I'm going to multiply by 5. I'm going to multiply x by 5. So pay attention that I'm not multiplying the 5 by 5. I'm multiplying the x by 5 above my fraction. Okay? I'm also going to multiply by 5 on the other side. Since I did it on both sides, my equation's still equal. Well, 5x divided by 5. Well, 5 divided by 5 is 1. So again, this leaves me with these 5's canceling out, because 5 divided by 5 is 1, so I just have 1x. So I just have x, and 4 times 5 is 20. So let's check if that answer is right. Let's put 20 in for where x was in our equation. So x was here. Let's say this is 20 now. 20 divided by 5 is equal to 4. Is that true? Yes, 20 divided by 5 is 4. Therefore, x actually must be 20. Okay, so you can always check if your answer is right by substituting what you get for your answer for the variable back in. I should have done this first, but let's quickly look at the visual for this with our teeter-totter. So how do we show x divided by 5? Well, we could show 1x but we actually have only 1/5 of it filled in. 2, 3, 4, 5. So that X has 5 sections, but we actually only have 1/5 of it filled in. But the weight of that 1/5 is the same as 4 counters. Okay? Well, how much would 1 whole X be equal to if I was to fill this up? If I was to get 5 of these 1/5, so multiply it by 5, another section would be another 4 counters. Another section would be another 4 counters. Another section would be another 4 counters. And another section would be another 4 counters, which gives me, in total, 20 counters. So 1 whole X, the whole variable strip, is equal to 20, which is what we solved. Okay? So let's go through some more examples. So I have 8X is equal to 56. So X is being multiplied by 8. I want to get X all by itself. So to do that, I'm going to do the opposite of what's being done to it, which is divide by 8. I'm also going to do that on the other side to keep my equation balanced, keep our teeter-totter balanced, so that it's still true that these things are equal to each other. So on the one side, 8x divided by 8, well, 8 over 8 is just 1, right, as a simplified fraction. So 1x, we can just get rid of those 8s. 56 divided by 8 is 7. So I get x is equal to 7. Let's check. Let's check. I substitute my answer for what x is equal to into the equation. 8 times by 7 is equal to 56. Is that true? Yes. 8 times 7 is 56, and 56 is equal to 56. Check. Yes, I did my question right. I know this seems crazy, but what if you randomly made even a calculator mistake and you said, oh, x is equal to 8? Then when you actually substitute it in, you'll see 8 times 8 is equal to 56, but then you get 64 is equal to 56, which is not true. That's not true. So if you substitute in the correct answer, you will get that the left side is equal to the right side. But if you don't have the correct answer, then the left side won't equal the right side, and then you need to go check your work. Okay, x divided by 11 over here now. X divided by 11 is equal to 7. So x, I'm going to rewrite it, divided by 11 is equal to 7. So something divided by 11 equals 7. Some of you, again, might be able to solve this by inspection just by thinking of what that number should be. That's great. Still try to follow these steps. I want to get x all by itself on the one side. It's being divided by 11, so I'm going to multiply x by 11. 11 times by x, so above that fraction sign. And I'm also going to multiply 7 by 11. So I did it to both sides. Equation's balanced. These 11s cancel out because 11 divided by 11 is 1. And I'm left with x on that side, and that is equal to 7 times 11, which is 77. Throw that back in. 77 divided by 11, yes, that equals 7. My answer is right. Okay, so this method, we've been doing it with numbers that are, on your multiplication table. But if you have a calculator, you can solve anything. So I just made this equation here. 456x is equal to 18,364. We can follow the same steps. Obviously, I'm not good enough at mental math to just know what x should be here, to just think and solve by inspection. But I can follow the same steps. So x is being multiplied by 456. I want to get x all by itself on that side, so I'm going to divide by 456. Since I divided by 456 on the left, to keep this equal sign true, I'm going to divide by 456 on the right. So divide by 456, divide by 456. Well, 456 divided by 456 is 1. So that's when they cancel out, right? That cancels out. I'm left with x is equal to 1,836. Let me use my calculator. 18,364 divided by 456. That is equal to 40.27192,982. And it goes on and on. Now I can check, is my answer right? Well, let's see if 456 times by 40.27. Does that give me 1,800, I'd have to keep all the decimals in there to make it exact, but times by 456, yeah, that gives me just about that. So I know that my answer is correct. Okay, so you can always put what you find for your variable back into that initial equation to check your answer. Another example over here of division of a case where I could not do it mentally necessarily, but you can with your calculator and following these steps. So I have x being divided by 83. Now when I divide this by 83, I get 0.5. Some of you are probably like, that's weird. What number divided by 83 equals 0.5? Well, it must be less than 83. In fact, it's going to be half of 83. But let's just follow our steps. X is being divided by 83. I'm going to multiply by 83. And I'm going to multiply by 83 on the right side as well. I did it to both sides, so equation's balanced. 83 divided by 83 is 1, so I'm left with just 1x on my left side. And 0.5 times by 83, you could use your calculator if you needed to, is equal to 41.5. And there's my final answer. And you can substitute that back in for x in your initial equation to check. Okay, so those are sort of the steps that you take. Whatever is being done to x, if it's being multiplied by 3, then you divide on that side by 3, and you divide on the other side by 3 as well. And then you can just solve. Okay, hopefully that's making sense. If it's not, maybe re-watch it again. You can also check out some other YouTube videos, because there's probably some other people who are great at explaining it as well as I am. We're going to do some word problems. So Mike's age is 1/3 of Susie's age. Mike is 13. So write an equation that could be used to model this situation and then solve for how old Mike is. Okay, so maybe let's think of this. So Mike's age, Mike can just be M, is 1/3 of Susie's age, which is S. So how do we show 1/3 of something? Well, we show 1/3 of something by dividing by 3. Hopefully you sort of get that. Like 1/4 of something is that thing divided by 4. 1/2 is that divided by 2. So 1/3 is divided by 3. So is this Mike's age being divided by 3 or Susie's age being divided by 3? Well, it is 1/3 of Susie's age. So we're actually 1/3 of Susie's age is Susie's age divided by 3 is equal to Mike's age. Right? Mike's age is 1/3 of Susie's age. So S divided by 3 here shows me 1/3 of Susie's age. M is Mike's age. We're saying that those two things are equal to each other. You also have to think when you initially look at these sentences, just think who's older. So Mike's age is 1/3 of Susie's age. Okay, well, Susie is obviously older than Mike because Mike's age is 1/3 of her age. So you just keep that in mind for when you get your answer to make sure that it's reasonable. Okay, so if Susie's age divided by 3 is equal to Mike's age, but now we know that Mike is 13, we can actually substitute 13 in for M. So we only have one variable now. So now that we only have one variable, we can solve for what it is. So S is being divided by 3, Susie's age is being divided by 3. I'm going to multiply it by 3. I'm going to multiply by 3 on this side. Those 3's cancel out to just get the 1S, just Susie's age. And Susie's age is equal to 13 times 3, which is 39. And that makes sense. We were looking for an age that is bigger than Mike's. And in fact, it's 3 times bigger than Mike's, which makes sense if his age is 1/3 of her age. So here's the final answer. Okay, one more word question. Maybe just pause, try to do this by yourself first, and then start playing and see if you got the same thing that I did. Okay, welcome back because you paused it. So Bert and Ernie both went for a run on Saturday, but Bert ran 4 times farther than Ernie. Bert ran 18 kilometers. Write an equation that represents the situation and solve for how far Ernie ran. Okay, so first let's think, who ran farther? Well, Bert ran 4 times farther than Ernie. So Bert ran farther. In fact, he ran 4 times what Ernie ran. So B ran 4 times what Ernie ran. So 4 times E. We show that without the multiplication symbol, just 4E. So the amount Bert ran is equal to 4 times the amount Ernie ran. So this is our equation that we can use to help solve it. We're given some more info because we have 2 variables here. We're told that Bert ran 18 kilometers. So I can substitute that in for B. So I get 18 is equal to 4 times by E. I want to figure out what E is, how far Ernie ran. E divided by 4, because E is being multiplied by 4, so I divide by 4. I divide by 4 on the other side, keep my equation balanced. The 4's cancel out. I'm left with 18 divided by 4. Well, it's not a whole number, but 18 divided by 2 is 9. You divide that by 2 again, see what it's divided by 4, or you use your calculator. Calculators will be okay in this unit. And you get 4.5 is equal to how far Ernie ran. Okay? And does that make sense? Well, we're saying Bert ran 4 times farther than Ernie. So if Ernie ran 4.5 times by 4, well, hey, that's 18, and that's how far Bert ran. So yes, if it's Ernie ran 4.5 kilometers, that makes this situation true. Okay, so there's some examples. Watch it again if you need to. Then do the assignment in the textbook and submit the Google form. I just also wanted to go over, I put on the link to the Solve Me mobiles again. You can go to the Solve Me mobiles, and I'm just going to show you some things that you can do with these. Okay, so this is puzzle number 125. Now they tell us that each purple is worth 5. So this is 5, 5, and 5. They don't tell us what the triangles are worth, the yellow triangles, and they don't tell us how much is up here. So you look at that and you're like, okay, well, couldn't the triangles, like what could they be? They could be anything because we don't have a total that we need to have these add up to. I'm going to show you a little trick that you can do that sometimes helps with some of these. It doesn't always help. Can I do it without my mouse? Okay, just a second. I'm going to reach to my mouse. You can, with your mouse, grab a crossbar on a puzzle, drag it to the side, and ching! It makes this little equation for you. And now what you can do is if there is the same shape or symbol on each side, so there's a triangle on each side, you can grab it, drag it down, and it gets rid of one of them on each side. So it's still balanced because it took away one triangle on each side. And now it gives us this equation. And this equation says a triangle is equal to 3 times what a purple diamond is equal to. Okay? You're like, well, how does that help you? Well, we know that a purple diamond is equal to 5. Therefore, our triangles are equal to 3 times by 5. Therefore, our triangles are equal to 15. And then you can type that in there. Oh, can I reach? I'm attached to my computer with my microphone. Is equal to 15. Let's enter that in. Enter. Oh, what the? Stop that. There we go. Let's submit. Yay! Okay, so that's 15. Okay, so you can pull that over. So let's look at number 126. Let's erase this. Okay, so again, you can grab this top bar. You can pull it over. And then you can drag down. So I'm going to drag. So I'm getting rid of one red on each side. So now I just have 2 reds on this side, no red hexagons on that side. I can pull away. Since there's triangles on each side, pull them away. Now I'm left with just one here. So it simplifies these equations for you, and which can be useful sometimes. So in this case, we're told that the total is equal to 30, and then we have these amounts. We're not told anything down here. So I know that each side would be equal to 15 because the 2 sides are balanced. But now I have to figure out, okay, well, what combination of things would this be? Well, I do know, because of my equation, this isn't necessarily, you could probably figure out without this, but it's a little bit helpful. that 2 of the hexagons is equal to 1 triangle, or therefore a triangle is worth twice as much as a hexagon. So these could not be 5, 5, and 5 because a triangle is worth twice as much as a hexagon. It could also not be 8 and 8 and 4 because that adds up to more than 15. But if you think of something else, 6 and 6 and 3, well, hey, 6 is twice the amount of 3, which is what I have here. If I put this 3 in for here, 2 times 3 is equal to, I said my triangle is 6. Yeah, 6 equals 6. That's right. Those must be the solutions. And so I said that is equal to 3. My triangle is equal to 6. Is that right? Yay! Okay, so that's just a little trick that you can do with these, is to pull that to the side. You might find it useful. Let's go to the next puzzle. Okay. Also, though, just a reminder that some of these are quite challenging. They don't always use whole numbers. So, for example, this one, the total is 10 at the top. That means each side must be equal to 5. We've been told that these pink hexagons are equal to 9. So this pink hexagon is equal to 9, and yet this side is equal to 5. That actually means that these are negative, and they would actually have to be equal to -4 for this whole side to equal +5. So if that's equal to -4 as a total, they're each actually going to be equal to -2. So you could enter that in. Okay, so I know that it's -2. How do I... There we go. And what about this yellow triangle? I know that the total is 5, so 5 divided by 2 is 2.5, so a yellow triangle must be 2.5. It actually doesn't let you write it in as a decimal, I don't think, so you have to write it in as a fraction. So that's 2.5. Which is equal to 2.5 is the same as 5 over 2. So I think that you have to write it in as that. So 5. Whoops, not typing. 5 divided by 2. And it shows it as being balanced. Submit. There we go. Okay, so you actually have to show it as an improper fraction for some of those. So some of these are really hard. You don't have to do those really hard ones. Maybe go back to some of these puzzler ones are probably a good place for lots of you to go. But if you want to, of course, just challenge yourself with whatever ones. There's some really, really fun ones, really hard ones. So yeah, once you are done your other work, feel free to do some of that. Okay, see you later, grade 7s. Have a good day.